Charles' law began from the French philosopher Joseph-Louis Gay-Lussac, who credited the unpublished work from Jacques-Charles. Gay-Lussac was the first to demonstrate this law. Charles' law could also be known as the law of volumes. It is an experimental gas law which describes how gases expand when heated. Charles' law describes how a gas expands as the temperature increases, and as the temperature decreases, the volume will also decrease. Charles' law can be written in this way. V1 over T1 equals V2 over T2, where V1 is the volume of the first gas over the temperature of the first gas, which is written in Kelvin. V2 is the volume of the second gas over the temperature of the second gas. Charles' law could also be written as V1 times T2 equals V2 times T1.
Here's a practice problem for Charles' law. You start with the information given to you. We have 5.3 liters is one volume, 12 degrees Celsius is one temperature, volume 2 is unknown, and temperature 2 is 80 degrees Celsius. You change the Celsius into Kelvin by adding 273. So 12 degrees Celsius goes to 285 Kelvin, and temperature 2, 80 degrees Celsius, goes to 353 Kelvin. To solve the problem, use the equation V1 over T1 is equal to V2 over T2. So you do 5.3 liters over 285 degrees Kelvin equals V2 over 353 degrees Kelvin. You do 5.3 times 353 divided by 285, and you get the unknown volume V2 to equal 6.6 liters.
Hey guys, today we're going to do an experiment demonstrating Charles' law. So first, you need a pot, boiling water, a pot, ice cold water, one balloon, one measuring tape, a thermometer, and something to record all of your data. Alright guys, first what we need to do is record our room temperature. And my thermometer is saying that it is 71.9 degrees Fahrenheit. We also need to record the circumference of our balloon right here. "20 inches. Perfect. So we're going to record that. 20 inches. Cool. Alright, now it's time to do our cold water test. As you can see, the temperature of the cold water is 43 degrees. It's going up now because I took it out. It's 43 degrees. It's much less than the room temperature. So we're going to submerge our balloon in this cold water for a period of time and see how it changes the size and the shape of the balloon. Alright, so as you can see, we've been holding our balloon underwater for about 45 seconds now, and it's really cold. So we're going to leave it on there for a couple more seconds, then we're going to pull it out, measure it, and see what happens. The balloon's been in there for 3 minutes. We're going to take it out, measure it, and see what's happened. Just over 19 inches. Alright, so while we're waiting for our balloon to return to its normal circumference of 20 inches, we're going to record our hot water temperature, which is 203.5, 204. So we're going to go 203.5. So you can see the circumference is at 20 inches. We're going to pop it in this hot water just for a few seconds. And we're going to see that it immediately starts expanding. This is really hot. Almost up to 21 inches immediately. And it's still going. So we're just going to assume that as soon as we take it out, it immediately cools and we can't get an accurate reading. So reading it in the water like this is the best way to do it. So we're going to go with a final number of 21. So we know that Charles' law is V1 over T1 equals V2 over T2. So theoretically, as your temperature increases, you should get a larger volume. And as your temperature decreases, you should get a smaller volume, which has happened here. So we've proved Charles' law. Good job, Charles. And we're done.